So we have discussed the equivalent circuit, exact as well as approximate circuits. Okay. Now one important point here before you start solving problems is the per unit value of the impedance. So we have already discussed the per unit values in power systems, but we will go through a basic revision. Okay. So what is per unit value? This is going to be the ratio of the actual value and the base value. Now the base values, how do we set? We set the base values for two quantities. Usually that is going to be the voltage. We take the rated value as the base value. Let us say this is represented as VB, and we take another value. What is that? Apparent power, volt ampere. Okay, so this also we take the rated value as the base value. So this if you represent as VAB. Then the other parameters, the base values of other parameters we get from these two values. Okay, for example, current base value, how will you find out? IB is equal to the base value of volt amperes divided by the base value of voltage. And similarly, impedance, how you are going to get? This is going to be the base value of voltage divided by base value of current. Or if you want to express in terms of volt ampere itself, then VB square divided by VA base. Okay, so this is how you set the base values, and then per unit value you can find by this ratio, actual value by base value. Now when it comes to the transformer, 2 points we have to remember. The first one is the base value of MVA, right? The base MVA, it is going to be same on primary as well as secondary side, right? So there is no issue here. But when it comes to the base voltage, okay, here it is going to be different. For primary side, the primary side rated voltage is going to be base voltage, and on the secondary side, the secondary rated value is going to be the base voltage. Okay, and accordingly the base values of current and impedance are also going to change. And the second point is the per unit impedance, it is going to be same whether it is referred to the primary or secondary side. Okay, so here we will try to do a problem on per unit system so that you will become more accustomed to this. Okay, so here we have a circuit, we have a source here, voltage source, and here you have a transformer. This is what? It is a step up transformer, 1:10. Okay, and here we have an impedance and another transformer here which is the step down transformer. Okay, 20:1, and here we have the load impedance. Now the base values are given as 480 volts and 10 kVA at the generator. The first question is find base voltage, current, impedance and apparent power at every point of the system. Second question is obtain per unit equivalent system. So whenever we have a transformer, we saw that the MVA or the kVA, it is going to be remaining same on either side, but the voltage levels are going to change, the base voltage levels. Okay, so we will see how to solve this. First we will redraw the circuit. Now let us say this is transformer 1 and this is transformer 2. Okay, now here we have the primary of transformer 1. So to the left of this we will have the same base values. To the right of this we are going to have different base values. Okay, and similarly for this transformer, to the left of the primary you have one region, to the right of the transformer you have the other region where the base values are going to be different. Okay, so this we will consider as region 1, and this entire thing we will consider as region 2, and this thing will be region 3. So you have to note that this secondary of transformer 1 and the primary of transformer 2, they are going to have the same base voltage values. So if you consider region 1, the volt ampere values, the apparent power, it is going to be the same, base apparent power, it is going to be 10 kV only, right? The base value it is already given. What about the base voltage? This is going to be 480 volts. So this we will represent as S base, and this is voltage base. Okay. Now what about the current base value? This is going to be S base by V base. So this is going to be 10,000 divided by 480, which is 20.83 you're going to get. This is the base current value. And impedance base, this is going to be V base by I base, and this will be 23.04 ohms. Next, in region 2, here also the apparent power, this is going to remain as it is, 10 kVA. What about the base voltage? So here we have the transformer ratio as 1:10. So if 480 volts is the voltage here, then 480 into 10, 4800 is the base voltage on the secondary side. Okay. So here V base is going to be, you can represent this as 2 here, okay, just to differentiate. This is VB1, SB1, IB1, ZB1. So VB2 you can find from the voltage ratio, right? VB1 by VB2 is equal to 1 by 10. So this gives you VB2 is equal to 4800 volt. Now similarly, you can find out the base current. This is going to be 10,000 divided by 4800. So this is 2.083 amperes. And base impedance, similarly this is going to be VB2 divided by IB2, and this you're going to get as 2304 ohms. Similarly, you can find out for region 3. So in region 3, SB3 will remain same, and VB3, this you can find from the voltage ratio. VB2 by VB3 is equal to 20 by 1. This is the given turns ratio. So here you are going to get VB3, this is equal to 240 volts. Okay. Similarly, you can find out the base current and the base impedance values. Okay. So I'm writing the final answer. This you're going to get 41.67 amperes, and ZB3 is 5.76 ohms. This is the first part of the question, to find the base values for each of the regions. Okay. Next question is, we have to find out the per unit equivalent. Now we have the system here. Now we have to find out the per unit values of each of the voltages and the impedances of all of the components that are present here. For the transformer, in this question there is no impedance given, so we can ignore the impedance of the transformer for this question. Okay. So first we will start off with the per unit value of the voltage source. Vg per unit, this is going to be equal to, the actual voltage is also 480 and the base value VB1, right? So is also going to be 480, so you are going to get 1 per unit. Next, what you have, 20 ohm plus J60 ohms. So this we will take as impedance Z. Okay. So now we want Z per unit. Remember that this is in region 2. So we have to take the base values of region 2, right? So you are going to get here 20 plus J60 divided by Z base 2. Okay. So how much did we get Z base 2? 2304 ohms. So this, if you solve, if you calculate, you are going to get 0.0087 plus J 0.026 per unit. Okay. And next, Z load. So what will be the Z load per unit? Remember, this is in region 3. So we have to take the base values of region 3. So this you are going to get 10 angle 30 degrees divided by Z base 3. So this is 10 angle 30 degrees divided by Z base 3, you got as 5.76. So this, if you calculate, you are going to get 1.736 angle 30 degrees. This is in per unit. Okay. So this is how we find out the per unit values.